We are back once again. It is Daily LeetCode, day 152. I've been in deep contact with the moderators and administrators in the Hyperbolic Coding Chamber, as well as the advisory board, the council, and the stakeholders. And we've decided that it's time to move on. So I have to move on from ones and zeros. It pains me to say it is a necessary evil. But I learned way more than I ever thought I would on this problem, so maybe it was a necessary evil. But I know that the sessions this week definitely took a lot. So also I know that the grandmasters are shaking in their boots. So we're coming, and it's kind of a problem. So I think we're going to continue forward. Yeah, I've learned a ton. I think there's a lot of information in my head about the graphs I need to fix before I can see what's wrong with the problem. That being said, yeah, a lot of stuff about the DAGs and so on. But yeah, this was a deep problem. So basically, I know more about Dijkstra's than I ever wanted to know now. And also, we have a lot more to learn about graphs. So what this made me realize definitely is that I'm kind of a little off and on with the supplemental reading, so I have to stick with that. And I think I may have a new method to expedite this process. So in 30 days or so, we should multiply to about 18 problems solved a day. And then at that point, we'll be unstoppable. So that being said, we must move on. We'll come back to it, though. There was another problem a few weeks ago, maybe a month ago, that I spent a week on too. Then we had to leave. But I think the path through the maze has been permanently stained in my brain. So when we come back to this problem and we solve it, it's going to unlock a whole new portion of the maze and triple our brain power. So it's going to be pretty flames. But, you know, it's just as flames. The comments on the video. We have a comment from Island Eagle. Interesting profile picture as usual. The comment that says, Susie works in a shoe shine shop where she shines, she sits, where she shines. Okay, you got me. That is pretty funny. Okay, this dude is in the lab with these tongue twisters. So that was pretty flames. We have ADC, the Grandmasters, watch out. Facts. They are shaking. I've been in contact with LeetCode, and I realize now that the reason I can't solve ones and zeros is because they've actually placed a lock on my account. So the problem is actually 2 to 3 times harder on my account. So they added about 1,000 more test cases. So it's also why our solution hasn't been passing. So our version of the problem has never been solved before. So we'll have to return and solve it. What extension to get your tabs on the left at 439? This is actually the Arc browser. So not an extension, but you can go to arc.net and cop up. You know, maybe they should sponsor me, actually, now that I'm thinking about it. So yeah, arc.net is the browser. That being said, it's time to move on. We have to go back to doing regular problems. It excites me for mediums, though. And also, I realize now the physical process of doing the easies is preparing me for the mediums. But also, there's definitely a lot of easies in here that are kind of time wasters. So we have to plow through those. But then we'll get to the good ones. Because I think there's some introductory DP problems. And also, what was I going to say? Oh, yeah. Also, I'm realizing the time for me to do these easy problems is the time for me to bolster my underlying skills. So I should have been doing some more supplemental reading than I am doing. So I'm going to start that back up. And yeah, we should see 2 to 3,000% more gains, and then we'll be unstoppable. So we're going back to the regular problems. And one of these problems is called Find Common Characters. So here we are. And I think this session is going to be about 45-ish minutes. So given a string array words, return an array Did we solve this already? Oh, we haven't. Given a string array words, Return an array of all the characters that show up in all strings. Given a string array words, return an array of all the characters that show up in all the strings within the words, including duplicates. You may return the answer in any order. Any order is pretty cool. So we're given Bella, label, and roller. And all the characters that are the same are E, L, L. Interesting. And we have cool, lock, and cook. All the letters that are the same are C and O. Words dot length. The array is up to 100 elements long, and each individual string can be up to 100 characters. Only consists of lowercase English letters. That's pretty useful. On first thought, I'm thinking something with a map. If we loaded all the characters into the map, we'd have B-E-L-L-A. We'd have 4 keys, B, E, L, and A, with 2 occurrences for L-L. Then we'd have label. If we loaded that into the map, we'd see that L is in there. Also, L is also in there. And B is also in there. Okay. Interesting. I think we could do this with a map. So I think what we would do is we create the first map with Bella, and then what we would do is on each string after Bella, we would pretty much take the union of what the contents of the map and the union of the contents of this map, and then we just take the union. So we just keep the ones that exist in both. And then I think if we kept doing that going through, we could then rebuild the output string based on what remains in the map. So let me see if I can visualize that solution. First, you'd have to have the solution map, which is going to start with the first string done, which is going to be Bella. Then we iterate through the rest of the strings. We could have a function called union map, which will just take the union of 2 maps. And then it'll return the map of the union. In the cases where we have multiple occurrences, the union of the map will take, if they're the same, they'll just keep the number. So if we have L, we'll keep the occurrences of 2. If they're not the same, then we'll take the smaller one. But it first has to exist in the map. So I think that would work. So just the approach would be initial map, then union of continuing map. I feel like this would take O of S, where S is the sum of all the characters in the string, and constant space, since we can guarantee that the word sub I consists of lowercase English letters. So maybe we'll have something like solution map, which is going to be a new map of type string to number, and then we'll have something called the temporary map, which is just based on the current string. actually create another function called string to map, and it's just going to take a string and it'll just return a map type string and number. And what we're just going to do is we can just copy this. We'll rename this to map, and then we'll just iterate over the letters in the map. So we'll say for const char of s, we'll say value is equal to, if the map has the character, right, then we're just going to get the current value of that character. Otherwise, we're going to set it to 0, and we're going to do map.set char value plus 1. Then we can return that. And so what we can do here is replace this with string to map word sub I, word sub 0, and then from here we can set let I equals 1, I is less than words dot length, to go through the rest of it. And then here we're just going to take the union, and then down here we should just have to convert that to array. Okay, so we have the solution map. So we'll pretty much say solution map is equal to the union map, or just create a function called union, and it'll take the solution map and the temporary map. And then I think that's all we should have to do. So then we just have to implement this function here, which will be union. We'll say take map1, which will be a map of string to number, map2, which will also just be a map of string to number. It's just going to return a map of string and number. And here we'll create the map. So how are we going to create, and then we'll just return U. How are we going to do the union? So I think we can just go over the keys of either one, since the union would have to include both keys. So what we'll do is we'll just, if we did that, then we'll check if the key exists in both, and if it does, we'll know we can add it to the union. And then from there, the actual number of occurrences you get is going to depend on the actual number of occurrences. So we'll say for const letter of map1 dot keys, and then we can say if map1 dot has letter and map2 dot has letter. Then what we'll do is we'll say U, which is the union, right? We're not going to add a letter for it. We're going to add a key into the union map, right? And the occurrences is going to be the math. I think we can just do the math.min of map1.get letter and map2.get letter. That way, if they're the same, then they'll just get the same value, but the occurrences have to match. So if there's 2 in one string and 1 in the other string, we have to take the 1. And then from here, we just have to build the string. So we can just say for const letter occurrence of solution map. We have an array called answer, and this is what we will return. Am I on the right screen? Oh, this is what we will return, and we're just going to say answer I is equal to 0, I is less than occurrence, right? I plus plus, we're going to push that many strings onto, that many letters onto the array. Oh man, we got the wrong answer. Oh, a temp map is empty. So temp map should not exist. What we should actually do is just run string to map for words sub I. Nice. So this is not that fast, but memory wise, actually 78%, 82%, even though runtimes vary widely. What would be the actual runtime? I know the space would be constant since we're using lowercase English letters, and that's going to use at max 26 characters in the map. And then this part would be constant because it's just 26 iterations at max. Actually, no, it could be more. But we could we're taking the union of this one and this one, taking the union of two maps, should take at max constant time since the maps come up to, well, no, it wouldn't take constant time because it depends on how many letters are in, the word. I'm thinking this is linear time, to be honest. Because even if we run string to map for every word, we really just end up reading every word in the string twice, which would just be 2 of s, where s is the sum of all the characters. We drop the constants. For each string, we count characters and count 1. Then we track the minimum count for each character and count. Auto I equals 0. I is less than 26. Let me think this through. Vector int, we have 26 indices in the vector. They have the result, which they'll return. Then they're iterating through every word in the string and getting s:(a), which I'm not exactly sure. I think a is the words, s is the actual string. Then they make a vector called count1, iterate through every character in the string and count the letters. Okay. Min of count I and count 1. I see. The min of count sub I and count sub 1 sub I, they're all initialized to infinity, which means if there's none of that character, the default value is 1. If there's none, then it would get 0. That's clever. I equals 0 as in 26. Interesting. Yeah, I guess you could technically break it down. I like the higher order questions though. So vector array is definitely very clever. Are there any more problems? I think we had a problem called valid to sum 4. Input is a BST? What is this? Oh, this is a bash problem. To sum 4, input is a BST. Given the root of a binary search tree and a target number k, given the root of a binary search tree and the target number k, return true if there exist two elements in the BST such that their sum is equal to the given target. But there's a bunch of ways you could do this problem. I feel like you could just convert the BST to an array and then just do regular to sum. But they probably want us to use the BST. Because maybe you could go faster with the BST because it's log k or something like that, or log of n to get the value in the BST. K is 9. The two values that add to make 9 are 5 and 4. Return true. K is 28. There's no two values you can add together. That will give you 28. Yeah, I feel like you could do then just convert it to an array that would already be sorted. And then you could run a two-sum algorithm. And then I'm pretty sure there's a two-sum algorithm you can run just check if a complement is in. Check if the complement is in the map or something like that. Should be done in linear time, linear space. So that would be ignoring the BST though. You know what, let's try that. Array to BST to array to map based to sum. So to the array we could create R, which would be an empty array of numbers. We could create a function called traverse, which would take the root node as well as array. And this function traverse take a node, which is a tree node or null, and it would take an array of numbers and not return anything. Now this only works if the node exists, and then I think is it pre-order? Pre-order gives you, in a pre-order on BST gives you an array in ascending order. Let's see, pre-order would be NLR. So N. No, that's wrong. So it's got to be. Oh, no. in order is L and R. Pre-order would be N. Right, so it's in order, I think. So you go to 5, we go to 3, then we go to 2, go to left, can't print 2, right? Can't go right, so you go back up to 3, then you do N, then you go right, can't go left, 4, go back. Yeah, so I think it's in order. Do ands dot push node dot val, and then we would just do traverse node dot left. With node dot right. And I think if we do just want to see if this array comes out looking okay. So the array looks fine. And then we can just do const map, which is just going, I actually don't think we need a map. We just need a set. And how does this work? So we pretty much want to find if a number equals k. So we pretty much load all the numbers into the map, into the set, and then iterate over all the numbers in the array and check if the complement exists. So we load all these numbers into the array, then we iterate over all the numbers and say, okay, well, k is equal to 28. Is 5 minus 28 in the set? No. So we could check in constant time. So it'd be linear time, 2 more times. So we'll just say for const num of r. And then we'll do it again. We'll say if set dot has k minus number, well, actually, let me check something. If k is negative, well, what's the constraints for k? K can be negative. So what if k is negative 5? If we do k, which is 5, oh no, k is, let's say k is 0. Let's say the number is negative 5. K minus I'm pretty sure you can just write this and it's gonna work, but something about the math always confuses me. Output is true. The expected was false. So given just 1, is there a number you can add 1 to? Oh, right, that isn't itself. So maybe we want to do this at the same time, actually. I think that would fix our issue. Kind of slow. I didn't use the BST at all, though. But I'm pretty sure the time complexity would be linear time with linear space. But with the BST, you can probably do better. Given the root of a binary search string and target number k, return true if there exists two elements and BST sum is equal to the given target. Set.add. So this works, but with the BST, we can definitely do better. You can definitely do better. First thing in the BST, I'm pretty sure is like log of n or something like that. If we do set.add, I mean, we already solved it, so we should do the BST version. I'm pretty sure anything that takes linear time is a bust. What if we just start at a node, and we say 5, k minus 5. We just know we're looking for 4, so we go left, right, then we go right. And then once our thing is greater than it, where the node is null and we didn't find it, let me just reset this. I forgot. BST based solution. You gotta go fast. Gotta go faster. Root of a binary search tree and a target number k. Return true if there exist two elements in the BST such that their sum is equal to the given target. It's got to be, I see the BST solution. I guess I'm not convinced that it's fat. I guess we'll see when we run it. Or I guess you need all the nodes ahead of time to find the complement. So we end up with linear time anyway. So if you can, so I don't, understand. DST based solution. I don't know if it table DFS. You could also just treat it like a graph. These don't feel any faster than just, maybe I'm overthinking it. Let me just see. Yeah, it all ends up with linear time anyways. Yeah, I was just going in a circle then. It doesn't make any sense. So, yeah, we'll just move on from there. Given the head of the singly linked list, return the middle node of the linked list. There are two middle ones. There are two middle ones, return the second middle. Yeah, I think you can do this with the two-pointer approach, but returning the second middle part seems a little convoluted. Because in this case, right here, boom, boom. Second pointer would be at 3. We move 2 to 3. Second pointer would be at 5. Oh, never mind. Maybe it works fine. So we'll just say, and we'll just say let temp equals head. Actually, they'll both equal head to start. We'll say, well, temp is not equal null. Temp is equal to temp.next and prev to temp. No, prev is equal to prev. Oh no. Oh no, it is not prev. It's just we'll just call this temp 2. It's not the previous one. It's just that it moves a little bit slower. So if we look here, temp would equal head. Temp 2 would equal head. And it would actually be easier if we just call this turtle and rabbit. Turtle starts here, rabbit starts here, rabbit moves 2 forward, and then turtle moves 1. Then rabbit moves 2 forward, then turtle moves 1, and then rabbit moves 2 forward. No. At null, and then turtle ends up at 4. You can just return turtle dot What about when the list is empty? I just realized. Rabbit.next. What does it mean it can't read it? Oh, I think it's about rabbit.next is not equal null. Let me just think this through. I'm trying to just regurgitate something. Both start at 1, while rabbit.next is not null. Rabbit.next is not null. 2 is not null. Right, then we do rabbit.next.next. Total equals 2. Then we do 3.next is not null, so we do rabbit.next.next are 5 now. So it's at 3. Do rabbit.next not equal null. Then we do rabbit.next.next, which does not exist. What is going on here? I think I'm just trying not to think, or I guess I'm tired of thinking. It always makes things take longer. Why are we getting TLE? I feel like we made that take so much longer than it had to take. I also don't like that I used all these safe navigation operators. That was really ghetto. Yeah, rip. Sometimes I just hate thinking, which is unfortunate because it makes things take longer. This is SQL. This is also SQL. Maybe it's worth it to do the SQL ones. You are given an array of strings, words, and a string. Actually, I have to check something just real quick. You're given an array strings, words, and given an array of strings, words, and a string cars. Okay. A string is good if it can be formed by character. A string is good if it can be formed by characters from cars. Each car can only be used once. There's a lot of different ways you could do this. Return the sum of lengths. Return the sum of lengths. Return the sum of lengths of all good strings and words. So cat and hat. The strings that can be formed are cat and hat. So the answer is 3 plus 3 equals 6. Words are hello world LeetCode, and the cards are well done honey. You can only make hello and world from this. Okay. I think we could write a solution similar to what we just did with the union one. But we could do a different solution with the arrays. So I think we could just do that. We could have a word map, which is just the cars, our cars map, which is just the map of the characters that are good. And then we can have a function that turns a word into a map. And then we can just have a function that has a validate map. When we're in that function, we just have to check that all the characters in the secondary map exist in the word map, and the occurrences are less than or equal to them. So we could create a function called string2map. And it's going to return a map, a string to number. And then we're going to return the map at the bottom. Then from here we can say for const car, I can't type today, of stir, we'll say const value is equal to if map dot has car. Then we'll get the value of car, otherwise we'll set it to 0, and then we'll say map dot set car value plus 1. We'll have cars map is equal to string to map of cars, and then we'll have let count equals 0, return count. From here we can do for const word of words, say, and we'll make a function called can be formed. We'll pass in the cars map and string to map of the word. We'll do ct plus equals word dot length. And then we have to write the can be formed from function, which is going to basically just take maybe it's probably not guys to put the data structure in the name. Don't know if it's a good idea to put the data structure in the name. It's a little bit redundant. And it's going to return a Boolean. From here we can just look at for const letter and occurrences of the word map. If you make it to the end, it's good, and if you don't, we'll say if valid cars dot get the number of letters we have for this character, right? We'll get the number of occurrences we have. Let's say we have 2 C's allowed and this word has 3 C's. We'll have to make sure that the occurrences less than or equal to valid cars, or if occurrences are greater than valid cars, then you return or if valid cars does not have the letter I think that's the last one for today. I also just realized LC added like 300 problems. So it seems, yeah, we'll just stop there for today and we'll wrap it up.